Julia McPherson is heading a team which is looking at the fastest growing scientific research area, nanotechnology. It's a 3-year project and she and her team are a year in. But what exactly is nanotechnology?
Anything on a length scale that is smaller than 100 nanometers or less. So just to put that into context, if you think about the diameter of a typical human hair, it's about 1,000 times smaller.
When it comes to researching nanotechnology, you can't just work with everyday equipment. The optical microscope is simply not strong enough for what Julie and her team need. What's needed is this, the AFM, the atomic force microscope to you and I. With an AFM, the critical part is the probe, and to see the finest detail possible, you need the finest tip, the carbon nanotube.
Imagine taking a film of carbon atoms and folding it up into a tube, and you have your carbon nanotube.
So what exactly are you and your team doing in terms of the research here at the University of Warwick?
One of the key things for us is actually to place them onto the AFM tip to give us these high resolution probes, but to be able to do this in bulk and at low cost, so these tips become affordable to everybody in the community wanting to work in this area. These carbon nanotubes, they have amazing properties. They're very good conductors of heat. They have extremely high strength, they're very flexible, they're very good conductors of electricity as well. So people are taking these properties and using them in lots of different types of product development. So for polymers, for strengthening polymers, the new generation of electronic devices, we're using them for the new generation of scan probe tips. They're a fascinating material.
Carbon nanotubes potentially represent the next generation of electrical circuitry to be used in all things like laptops, computers and mobile phones, so impacting our everyday lives. With carbon nanotubes, all services can be explored in depth. For reading Braille, fingers go across the surface to detect words, but with AFM carbon nanotube tips, you can analyse what feels like a completely flat surface, such as a DVD, at very high resolution.
Here's a very basic model of an AFM probe, and I need you to use this. It's a laser pointer because it's an integral part of what we're going to show you. Basically, what we have here is a very flexible beam, and attached to it is a tip. So imagine this is our surface, and as we scan the tip over our surface, you can see that the tip will move up and down to follow the contours of the surface. So how are we going to measure the reflection of the beam? Here we come. We're going to shine a laser pointer onto it, and it's going to go into some type of detector.
I see.
Okay.
So as the lever moves over the surface, the laser records the movement.
Exactly, and we get an image of the surface structure. But as you can see, that tip's pretty big. Okay, so the sort of representation of the surface structure is not going to be as accurate as we like. So ideally what we want to be able to do is place something like this onto the end of the tip to give us the ability to probe the surface structure in a lot more finer detail.
And that is your carbon nanotube.
Exactly.